Hello, welcome to a lesson on graphing exponential functions. So, you've been working with properties of exponents. Now we're going to graph some functions that are going to use our bases with their exponents. So first we need to do a quick review. So we're going to do a review of our input-output tables, because all we're going to do for these are input-output tables, because that's the easiest way for us to do them. So we're going to start with y equals 2x, and the five numbers that we're going to pick are the -2, -1, 0, 1, and 2. Now the first time we did input-output tables, I said, hey, you can pick anything you want, but these are the numbers I prefer. When we do these exponential functions, these are the numbers I want you to pick, and you'll see why when we actually do one of these. It's pretty crazy if you were to pick numbers that are more negative or positive than these. So what we're going to do is we're going to input our x values into our function. Because our function's like a machine. We put something in, it spits something back out. So we get a -4. We plug in our -1. We get y equals 2 times -1, which is -2. We get x equals 0, so we get y equals 2 times 0, which equals 0. I should probably plug these in here, shouldn't I? We do the 1, we get 2, we plug in 2, and we get 4. So there's our quick review on how to do an input-output table. Okay, so here we go. Our first exponential function that we're going to graph. It's f of x equals 2 to the x. So it's going to work the same way. We have our input-output table, and we're going to plug in our values here for x. So when x is -2, we get 2 to the -2. And when I plug that in the calculator, that gives me 0.25. I'm going to do -1, so I get 2 to the -1. Put that in a calculator and it gives me 0.5. 0, 2 to the 0. We remember that anything to the 0 power is 1, so this becomes a 1. 1, 2 to the first power is 2, and plug in 2, 2 to the second power is 4. So here we have our 5 points that we're going to plot on our graph. So we're going to plot them, so -2, 2.5, I'll change colors, so this will be in red, -1.5, 0, 1, 1, 2, and 2, 4. Now, I'm going to go back to our first here. Y equals 2 to the x. That's a line. That's a straight line that's going to look like this on a graph. Our exponentials are not straight lines. As you can see, we can't draw a straight line through this and hit all our dots. There's no way. This is actually going to be a curve. So this is a curve, and it's a curve that's starting low and it's getting bigger very quickly. Now, whenever our curve goes to the negative, it actually is never going to go below x equals 0. So none of these are ever going to be in the negative y's. It's always going to be positive y. And with this curve, as you can see the way I drew it, as this goes up, it's going to go up very quickly, because we look at our exponential. We go from 0.25 to 0.5 to 1 to 2 to 4. So it's not like we're going up slowly. We're going up very quickly with these. So here's our first curve. So let's compare. Now, I already told you a little bit of what I wanted you to see with this, whereas our 2 to the x kind of goes up very slowly, and our 2 times x goes up slowly, and our 2 to the x goes up very quickly. But now I want you to pause the video and look and see how much are each of these going up. Okay, so let's take a look at that. So we look at our y equals 2 to the x. So if we go from here to here, and we're just looking at our y's, so we look at our y's, and our y goes up plus 2. We look here, we have another plus 2, and a plus 2. So every time we're adding 2, because that's what our slope is, it's 2. So we're going to add 2. We look here, 0.25 to 0.5, well that's times 2. 0.5 to 1 times 2. 1 to 2 times 2, 2 to 4 times 2. So with our exponentials we are multiplying. So this number here says we're multiplying by something. Whereas with our y equals 2 times x, we were adding. So that's why these can go up very quickly or they can go down very quickly, because we are not adding something, we're multiplying. So that means this 4 is going to turn into an 8. That 8 is going to turn into a 16. That 16 is going to turn into a 32. So very quickly we can get into some big numbers. Okay, so now we have 2 more examples to do and then we'll be done. So this example, we have f of x equals 4 times 1/2 to the x. So this time our base of our exponent is a fraction. And let's see what happens when we do that. So we're going to start off with our -2. So we do 4 times 1/2 to the -2, and this is why calculators are nice. All you got to do is plug that in the calculator and it'll give you what you need. And what I was doing was stalling time, so I could plug that in the calculator and you get 16. We go -1, so 4 times 1/2 to the -1, which gives us 8. We plug in 0, 4 times 1/2 to the 0, and we get 4. Plug in 1, we get 4 times 1/2 to the 1, and we get a 2. 2, 4 times 1/2 squared, which gives us a 1. So this one, we're actually going down. We're going down. Because this is a fraction, because that right there is a fraction, it means we're going down. So we can say that if we have our a to the x, so if a is bigger than 1, we go up. If a is between 0 and 1, we're going to go down. So let's put these on a graph. So -2, 16. I wonder if I have 16 dots. Oh, exactly 16. So 2, -16. Then we need to go to -1, 8. 0, 4. 1, 2, and 2, 1. So as you can see, this curve is headed down. And it's still never going to go below our x-axis. But this one starts to go down very quickly and then begins to slow down the further we go to the right. Whereas when we looked at our first one, it started slowly going up and then went up very fast. So if it's greater than 1, it also is going to go up fast. If it's between 0 and 1, it's going to go down fast and then slow. Alrighty. Last example, I want you to try this one on your own, and then when you're done, play the video and see what happened. So go ahead and pause the video now. Alrighty, so here are the solutions to that. As you can see, it was a 3, so that means we were going up. So go ahead and check your work with mine. After you do that, this video is over.